So our lesson 2 for chapter 1, still sequences and series, is will talk about the general term of a sequence. So we have here, let's try to consider 11, 15, 19, 23, and 27, and so on. If we try to ask what is the 100th term of the sequence, if we do it manually, it will take us time to compute for 100th term. So maybe we need some kind, because we know the rule, we can make some kind of a sort of a formula to generate that certain term, the 100th term. So when you say a general term of a sequence is actually the formula that generalizes the sequence. So this is the formula that we use to determine any specific term of that sequence. So this general term or this formula, this is also known as the nth term of the sequence. So for clarity, we shall take the first term as a sub 1, the second term as a sub 2, and the nth term as a sub n. So in the sequence above, a while ago, we have, so our a sub 1, our first term is 11, our a sub 2 is 15, our a sub 3 is 19, our a sub 4 is 23, our a sub 5, our fifth term is 28, and so on. Our a sub n is actually our general term. So let us say here, suppose a sequence is defined by a sub n equals to n minus 3. List the first 5 terms of the sequence. So for n sub n equals 1, that means we are looking for the a sub 1 or the first term of the sequence. So we'll simply replace the n equals 1 in the equation. So we have 2n minus 3, you have 2 times 1 minus 3 equals negative 1. This means that the first term of our sequence is negative 1. Then for n equals 2 means we are looking for our a sub 2 term or the second term. That is 2 times 2 minus 3, that gives us 1. So the next term is 1. Our n sub 3 equals a sub 3, which is 2 times 3 minus 3 equals 3, and that gives us 3. Our third term is 3, and so on. Our fourth term is 2 times 4 minus 3, that gives us 5. And our fifth term is 2 times 5 minus 3 equals 7. So therefore, the first 5 terms of the sequence, and that sequence is defined by a sub n equals to n minus 3, are negative 1, 1, 3, 5, and 7. So we have here, suppose a sequence is defined by a sub n equals n squared plus 1. List the first 5 terms of the sequence. So we have our n sub 1 equals 1 squared plus 1, that is 2. Our second term is 2 squared plus 1 equals 5. Our third term, n equals 3, or a sub 3, we have 3 squared plus 1, that is 10. Then our fourth term is 4 squared plus 1, that is 17. Our fifth term is 25 plus 1, that is 26. Therefore, the first 5 terms of the sequence are 2, 5, 10, 17, and 26. Suppose a sequence is defined by a sub n equals 4n plus 3. List the first 5 terms of the sequence. So our first term is 4 times 1 plus 3. 1 being our n equals 1. So we have 7. Then our second term is 11. So this should be a sub 2. Then our third term is 15, a sub 3. Our a sub 4 is 19. Our a sub 5 is 23. The first 5 terms are 7, 11, 15, 19, and 23. So this time, let's consider this one, the sequence 5, 8, 11, 14, and 17. So what is the general term? Again, going back, general term is actually the nth term or the formula that we use to find any other terms. It's like a formula so that we can easily compute for any term of that sequence. Okay. So how do you do that? So a general term might be governed by one or a combination of 2 or more mathematical operations. So we may combine multiplication and addition, combine multiplication and division. So any other combination of mathematical operation. We can square, then add, we can square, then subtract, we can square and divide, square and multiply, cube or add, cube, then subtract, cube, then divide. So to get that, we have to put in mind, oh, the rule of that sequence is, number sequence is some kind of, the rule is governed by some kind of combination of operations. So let's try to continue. So if we have here 1, our n equals 1, the given is the first 5 terms. So our first term, n equals 1 is 5. Our second term, n equals 2 is 8. Our third term, n equals 3 is 11. Our fourth term is 14. Our fifth term is 17. Then our nth term is a sub n. So the question is, what operations or combination of operations that we are going to apply to 1 to get 5, combination of operation to get 2 to get 8, to that we apply to 2 to get 8, then what operations that we're going to apply to 3 to get 11, then so on. Okay? So when you try to combine that operation, you try to do some experiments in the first term. Then if you try that experiment, you try the same combination of operation in the second term, the same so in the third term and fourth term. So if it's true for all these 5 terms, that is our final rule for the sequence. So out of that, we can make a formula or the general term or the nth term of the sequence. So let's try to do this. So 1 to 1, n equals 1 is 5, n equals 2 is 8, n equals 3 is 11, and so on. So as you can see, the rule is multiply by 3 our n, then add 2. So the combination multiplication and addition. So multiply by 3, then add 2. So it's true for all. 1 times 3 plus 2 is 5. 2 times 3 plus 2 is 8. 3 times 3 plus 2 is 11. 4 times 3 plus 2 is 14. 5 times 3 plus 2 is 17. Since that is true from the first to the fifth term, we can generalize here is in our nth term. So multiply the n by 3, then plus 2, that is our a sub n. So this one, in this case, that is already our general term, our formula, or our nth term. So the general term of the sequence above, the 5, 8, 11, 14, 17, is actually just a sub n equals 3n plus 2. And that is from here. That is from here. Okay? So it's like the first 5 terms is just an experiment. Okay? If the experiment is true for these 5 terms, then we use that to generalize here in the nth term. So find the general term of the sequence negative 2, 1, 6, 13, 22, and so on. Sometimes it's really hard to figure out the negative. How come the positive goes to the negative? You can do that by either subtraction. So there's subtraction happening. If from positive it becomes negative. So look at this. 1 becomes negative 2. So, or maybe it's being multiplied by negative number, or it's being divided by a negative number. Okay. So here we have 1. The operation is square the n, the values of n, then subtract 3. Okay? And it's true for 1 to 5. So that is 1 square minus 3, 2 square minus 3, then 3 square minus 3, 4 square minus 3, that is 16 minus 3, 13, then 5 square minus 3, that is 25 minus 3, 22. Since this combination of operation works for from 5 from the first term to the fifth term, we can generalize here. Therefore, our general term is just a sub n equals n squared minus 3. So this serves as our the formula. So if we are going to ask, what is negative 2, 1, 6, 13, 22? What is the 20th term? Okay, 20th term. So the 20th term maybe, we'll just simply plug in 20. So that's 20 square minus 3. And that is 400 minus 3, that is 397. It means that when you do this, continue this pattern, and the 20th term will be 397. So find the general term of the sequence 1, 6, 11, 16, 21. The same idea. What operations are we going to apply to this value so that we get these corresponding values? Okay, so in a Cartesian plane, it's like this is the x and this is the y. These are the x values, these are the y values. So 1, what happened to 1? 2 becomes 6, 3 becomes 11, 4 becomes 16. What operation? 5 becomes 21. So subtract 5, then multiply by 5, then subtract 4. Okay? So 1 times 5 minus 4 is 1, 2 times 5, 10 minus 4, 6, 3 times 5, 15 minus 4, 11, 4 times 5, 20 minus 4, 16, and so on. Therefore, our general term is simply a sub n equals 5n minus 4.